Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Mashudu Mamburu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. You can communicate with us through WhatsApp on 063 629 3655. So for any question that you are having, please just send your questions. We will be able to answer during the lesson. As indicated, we are hoping that you will enjoy the lesson and we are preparing you for the prelim exams. So the topic that we are going to be dealing with is electrochemistry. Remember, electrochemistry is galvanic cell and electrolytic cell. So what we're going to do, we'll consolidate galvanic cell and do electrolytic cell. So it's a fully packed lesson, and if you listen and understand, you will do very well. Remember, for paper 2, we are still saying chemical change. Thank you very much. Sorry for the small technical issue. So as I indicated, we are busy with electrochemistry. We are saying we are dealing with paper 2. So we are doing the second paper, and we are saying this topic, chemical change, we have 28 marks, which is a weighting of 38% for paper 2. Remember, paper 2, we are still saying is 75 marks. You are writing paper 2 for 1.5 hours. And according to our timetable, you will be writing paper 2 on the 28th. So we are hoping that this is going to help you as you prepare for your prelim exam. So without any wasting of time, we'll move to the topic of the day so that you see what we are dealing with. So we are saying we'll do galvanic cell and then electrolytic cell. And then if you look from the diagnostic report, you will see that this topic, these questions is question 5 and question 6. So you can see how the learners performed in those questions, 31% and 29%. So it's still not a good performance. So we're hoping that after this lesson, you will improve and your cohort will be able to get good marks for this topic and you will make us proud. Now, as we move, we are saying table of standard reduction potential. That's where we want to start. Remember, you are having table 4A and table 4B. You always get them at the end of your question papers. And then we're going to take you through to say how are you going to utilize this table 4A and table 4B. We call the table of standard. So you can see already the word standard. It means that we are using standard conditions. So standard conditions, we have 3 standard conditions that we use. So the standard conditions are, condition number 1 is temperature. So it's a temperature of 25 degrees Celsius. So you must know that we have standard temperature of 25 degrees Celsius. We have initial concentration of 1 mole per cubic decimeter. So that is one standard condition. The third one is that we have a pressure of 101.3 kilopascals. Or you can just say 1 atm. So you must always know those 3 standard conditions. So we're saying this table, we achieved this standard reduction potential under these standard conditions. So if we change the condition, the values obviously will change of standard reduction potential. So it's important that you understand those tables. So all the time, in the event you are asked a question to say, write down 2 standard conditions, I will advise you to first write the first 2. However, if you have gases, then pressure will apply. So if you don't have gases, you can just simply name the temperature of 25 degrees Celsius and the concentration of 1 mole per cubic decimeter. And we're saying there are 2 tables. So as I indicated already, that we have table 4A and table 4B. So you must know at all times that we have two tables, table 4A and table 4B. These tables are similar, so they are the same tables, but entries are arranged in opposite direction. You will see when we go to the tables. For example, if you look at table 4A, you will see that it starts with positive numbers, more positive numbers, to less positive numbers, to negative numbers. You will see when we open the tables. And when you look at table 4B, you will see that it starts with the negative numbers of the lesser numbers to the more positive numbers that we are having. So the difference is the entries. To say table 4A, it starts with the positive, and the table 4B starts with the negative. So you got to differentiate between table 4A and table 4B. The tables of these two tables of standard reduction potential, they can be used for four things that I want you to know, that if you are asked this question, you can go to the table and it will be able to assist yourself. Now, number one, we are saying you can use this table to identify oxidizing and reducing agents. So if you get a question that says which one is a reducing agent, the table can help you to answer that question. So that is the first thing that the table will help you with. Number two, the second thing that the table will help you with, if we say identify the anode and the cathode. So you can see by merely looking at that this table will really help. To me, I look at it like it's a memorandum that you are given when you enter the exam room, so that you are able to answer questions. So when you are asked to identify the anode and the cathode, the table can help you to identify the anode and the cathode. Number three, we are saying when you are asked to write balance redox reaction equations, you are able to do that. Remember, we will ask you to write down the oxidation half fraction, the reduction half fraction. Then you can use the table even to write the overall or the net cell reaction. You still use the table. So you can see that this table, all in all, is your memo in the paper. Predict, you can as well use it to predict whether a redox reaction is spontaneous or not. Remember, if a reaction is spontaneous, when you calculate the EMF, you will get a positive answer. And if you calculate EMF for non-spontaneous, it will be a negative answer. So you are able to do that. Remember, spontaneous is galvanic cells, non-spontaneous is electrolytic cells. As I indicated to yourself, that we have two cells that we are going to deal with. Now, this standard reduction potential, it refers to the half fractions as a reduction. So if we look at all the values, as I will be opening the table now, you will see all of them are indicated as reductions, which means the number of the electrons will be on the left-hand side of your equilibrium equation. So the standard electrode potential values, they reflect the ability. I want to understand this one. They reflect the ability of the reactant to act as the oxidizing agent. So you have to understand that the one that is having the highest ability, which is the standard reduction potential, so you have to understand that it will be our oxidizing agent. So the one that is having the highest standard reduction potential will undergo reduction because it has standard reduction potential, which means look at potential as an ability. So you are saying it has a higher ability. You know that reduction is gaining of electrons. So you know that reduction is gaining of electron. So which means when you look at this table, you are saying this is the table of ability to do what? To gain electrons or to undergo reduction. So this is the ability to undergo reduction under standard conditions. So when you look at those values, the more positive value, it will undergo reduction. The less positive value will undergo oxidation. So you have to see how useful is this table. So as I indicated, that the more positive E value means that the reactant will be the oxidizing agent, and the more negative value means that it will be our reducing agent. So each half reaction contains both a reducing agent and an oxidizing agent. So I want you to understand here that when you look at this copper 2 plus, if you are having, so the 2 plus there at the top there is a superscript, copper 2 plus, they are gaining 2 electrons to form copper. And you have the zinc 2 plus gaining 2 electrons to form zinc. So you have to look at that to say the strong oxidizing and reducing agent reacts to form the weaker ones. So it becomes very easy. You'll see when you do the example that it is the reaction that we are going to have. It will be strong oxidizing agent and a reducing agent. Then they will form weaker reducing agent and oxidizing agent. You will see that when we deal with that. And then we are saying a spontaneous redox reaction will occur between oxidizing agent and any reducing agent that lies below it in the EMF series. So for spontaneous, as long as we are having oxidizing agent that is at the top of the table and reacting with any other substance that is under in terms of the table, it will be spontaneous. So the oxidizing agent is the reactant from half cell with the more positive E value. So you have to understand that our oxidizing agent has a more positive value. So I hope that will help you. Now, without any wasting of time, I would like to go to table 4A. You see, this is the table 4A. As I indicated, the entries there, you can see we're starting with fluorine. That is 2,87, positive 2,87. And the lowest standard reduction potential we're having is for lithium, which is negative 3,05 volts. So you can see the table 4A, we're starting with the highest standard reduction potential, followed by the lowest standard reduction potential. However, as you move to 4B, we are starting with a more negative number. Lithium now is at the top of your table, and at the bottom is fluorine. So hence I indicated that these tables are the same, they just different opposite entries. The other one starting with the more negative, the other one starting with the more positive. I hope you have understood that. Now, for the sake of our lesson, I will utilize table 4B for galvanic cell because it just makes it easier to do so. Remember, with galvanic cell, we're looking at the zinc copper cell. All of them are metals, and then we are able to indicate that all you have to do is that you copy the zinc as is written on the table. So you will go, if you are dealing with the zinc copper cell, what you will do, you will go to the table and look for zinc, and then you copy as is, then you write 2 electrons, it forms zinc, and if you check that, it will give you negative 0.76 volts. So it gives you negative 7.6 volts. That is given on the table. You are copying it as is written, and then from there you go to copper. You must be careful because we have different copper that are given that is given here, substances. The other one is copper plus. The other one is copper 2 plus. So you must be very much aware of which copper we are referring to. In this case, we are referring to a copper with 2 ions. So it's a copper 2 plus and 2 electrons to form copper with a standard reduction potential of 0.34 volts. So it's very much important for you to check which copper we're talking about if we have more than one substance in the table. So check, don't just go and take the first one, because you may find that those substances, they react, they appear more than once on the table. So check the entire table and make sure that you copied the right one. So now we are simply saying that the reaction, as we indicated, that the standard reduction potential, the positive 0.34, it will show you that this copper, it has the highest standard reduction potential, so it must undergo reduction. So it becomes easier. You will know that, okay, copper will undergo reduction because it has the highest standard reduction potential. I hope you get that, which means that zinc will undergo oxidation, which means when we write it, we're going to write it in a reverse manner. And then it becomes even much easier if you were to write Z there, and then you indicate the arrows there to say Z. Then the first one, you know that it will go backward, the second reaction will go forward. So it makes it much easier. But here, when you're using this method, ensure that you always start by copying from table 4B. You copy the first substance first, the second second, so that you don't have a problem of reversing them. So if you're using this method, be careful of that. Then immediately when you write your Z there, you're able to know that the first reaction will be oxidation, meaning that you will write it going in a reverse manner. So you will write zinc, forming zinc 2 plus 2 electrons. Why? Because we are saying zinc has a lower standard reduction potential. So it doesn't have an ability to undergo reduction. It has an ability to undergo oxidation. So for copper, you will be able to form your copper 2 plus 2 electrons forming copper. Remember, these are half reactions. You don't have to write double arrows. Immediately, when you decide which one is going to undergo oxidation, which one is going to undergo reduction, you must be able to write one arrow. We refer to this as oxidation half reaction, and the second one as reduction, half reaction. So when you write half reactions, there will be one arrow. Then you ensure that the number of electrons are balanced. If the number of electrons are balanced, like in this case, you can see that we have 2 electrons for zinc, we have 2 electrons for the copper 2+. If they are balanced, you can cancel them. Please be careful when you are writing the overall. We call this overall or net cell reaction. You can call it net or overall cell reaction. So when you write the overall cell reaction, ensure that you are having the number of electrons are balanced. You can see on the zinc one, we are having 2 electrons. On the copper 2+ one, we are having 2 electrons. So that helps you to say, since they are balanced, I can cancel them. You only cancel them if they are balanced. It's like when you're doing your maths, when you have a 2 on the left and a 2 on the right, you know that they will cancel because the other one, when you transpose, the other one becomes negative. I hope that helps you. So we cancel those electrons. Remember, what is on the left, you write on the left. When you're writing the overall or the net cell reaction, the substances that are on the left, we have zinc here. On the anode, you add it to the copper 2+. So you're getting overall, you write 1 arrow. Don't make a mistake of writing 2 arrows when you're dealing with the overall or net cell reaction. Then you write zinc 2+ plus copper. So you are able to do that. So you got 3 marks. That question will come with 3 marks. So please ensure that you collect those marks, because to me, I think it's a simple thing to do, and you practice until you understand that. The first thing is to go to the table, identify the substances that are given in the equation, and then you copy as they appear in the table. You write your Z with arrowheads to indicate that the first reaction that you got from table 4b, it will undergo oxidation, which is loss of electrons. So it's a reverse. You write it in reverse from zinc to form zinc 2+, and the copper 2+, because it has a higher standard reduction potential, you write it as copper 2+ plus 2 electrons forming copper. Then you balance the electrons. If the electrons are balanced, then you are able to write what is on the left from the oxidation and the reduction. Remember, you are combining them. That's why we're saying net, which is total. So you're combining the oxidation and the reduction. So you must be able to write what is on the left, you write on the left. What is on the right, you write on the right. So hence we said zinc and copper 2+ is forming zinc 2+ plus copper. So that is our overall cell reaction. Now, from there, we'll be able to ask from yourself to write our cell notation. Cell notation. Remember, for cell notation, you must be able to use ABC. So when you say ABC, you are saying you start from the anode. You get the salt bridge, then you have the cathode. So always when you start, remember, when you are doing the Z method, you are showing that the first one there is A. So it's easy to say A and C. A and C. Then you will see that the first one is anode, the second. So when you're using these tables, you know that A always comes before C. So you will, the one there at the top will be an anode, the one at the bottom will be a cathode. So the only thing that you must be careful of is which table are you using for what. So in the method that I'm giving you, you're using table 4b, it makes it much easier. So you are having your anode and your cathode. So you see for the anode, zinc becomes zinc 2+. So when you copy the anode here, you'll say zinc, you put an arrow there, then it gives you a zinc 2+, and you have your salt bridge. Then you have, for the cathode, you have copper 2+ becoming copper. You see, the line that you see, the one line that is separating zinc and zinc 2+, we call it a phase boundary. Phase boundary because your zinc is solid and your zinc 2+ is aqueous. So there are two different phases. Remember, solid and aqueous solution, there are two different phases. Hence, we are using a straight line as a phase boundary. The double arrow there is for the salt bridge. So the double arrow, you must know that it stands for the salt bridge. So don't forget that the double arrow stands for the salt bridge. Remember, the salt bridge has two functions, which is to complete the circuit and to maintain electrical neutrality. So you have to remember that at all times. So I hope that helps you. And then even when it comes to you calculating the EMF, you are able to say EMF, you will say E of a cell equals to E cathode minus E anode. I want us to finish this so that we can deal with activities. So we're having E cathode minus E anode. The cathode already you have decided when you say A and C here, you have decided that the cathode is the second one, because we said always A comes before C. So you know that, okay, our C is 0.34. So you are able to say, okay, 0.34 minus, remember, it's negative 0, for the anode, it's negative 0.76. Don't make it that mistake. Remember that it's negative, another negative. So it's negative 0.76. So a negative and a negative is a positive. Then that will give you 1.1 volts. Remember, we said this reaction is spontaneous because it's galvanic cell. It's spontaneous means that the answer here must be positive. So sometimes we can ask you to show that the reaction is spontaneous. All you have to do is to calculate the EMF. So I hope that helps you. Remember, learners, we are saying copy the formula from the data sheet. Don't write it from your head, because you make mistakes. You write short ECAT minus EAN, it becomes wrong. We are saying copy the formula as it appears in the data sheet. Those formulas are for free, so you're not paying for them. So just go and copy. I'm advising you to do so. Now, with no wasting of time, I've indicated the issue of the table. Now, I want you to give, before we start with questions now, because we're going to look at some previous question papers so that we see whether now you understand the concept or not. But the structure and tips, I want to give you structure and tips to say, how do you go about answering these questions? So we are saying, the first thing you must remember is energy conversion. To say, for galvanic cell, energy is from chemical energy to electrical energy. So when you say define galvanic cell, you will simply say it converts chemical energy to electrical energy. I hope you got that. Now, the second thing that you must know is the function of the salt bridge. As I indicated, that if a salt bridge completes the circuit, so it completes the circuit, without me repeating myself, I said it completes the circuit and it maintains electrical neutrality by allowing the movement of ions. So it allows the movement of ions. What are the ions going to do? Is to maintain neutrality. So it wants to maintain neutrality, maintain electrical neutrality. Now, how does it do that? Please let us remember, we are saying N ions, which are a negative ions, N ions is a negative ions. They will always go towards the anode. Don't forget that. Negative ions will go towards the anode, and the cation, which are the positive ions, will always go towards the cathode. Please don't forget that, because these are exam questions. Now, so I talked about the two functions of the salt bridge. I talked about the movement of the cations and the anions. I indicated that the anions towards the anode and the cations towards the cathode. So immediately when you know which one is the anode, which one is the cathode, already you will know the flow of the movement of the ions. We are saying standard conditions. I told you when we were dealing with the table to say the standard conditions, the temperature of 25 degrees Celsius, is an initial concentration of 1 mole per cubic decimeter, and the pressure of 101.3 kilopascals or 1 atm. Remember, learners, we're saying pressure, you use it when you are dealing with gases. So when you don't have gases, you will write the first two. Sometimes we do ask you questions to say, write down 2 standard conditions except. So always be careful of that, because if you are saying except temperature, write the other 2. So you can't write temperature because we said we don't want temperature. So be mindful of that when you are dealing with questions. Now another question that you must know, identify the anode and the cathode. Don't forget, we said an ox and red cat. So we are saying an ox and red cat. So we are saying at the anode is where oxidation takes place. When you're using table 4b, already I've showed you that the anode will always come before the cathode. So you are able to know that. Now, you must be able to identify the oxidizing agent and the reducing agent. Remember, at the anode, we are saying oxidation takes place, which means oxidation is a loss of electrons. So you have to know that where loss of electron is taking place, which is oxidation, that's where you will find the reducing agent, and that substance will be oxidized. Then we are saying your route to say loss of electron is oxidation, then you will get the reducing agent that is oxidized. And then we are saying the one that is gaining of electrons is reduction. That's where at the cathode. So we have gaining of electrons, which is the reduction, and that's where you will find the oxidizing agent. That oxidizing agent must be reduced. Now, you must be able to write half fractions of the anode, that is oxidation half fraction and reduction half fraction, as I indicated when I'm using the Z there, method there, to indicate that the first reaction will undergo oxidation, the second one will undergo reduction. You must be able to write the overall net reaction. Remember, I said to you that before you write the overall or the net cell reaction, you must ensure that the charges are balanced, the ions are balanced, the number of electrons are balanced. That is to say, if you have 2 electrons, there must be 2 electrons in both your reaction. Then you can cancel them, and then you write what is on the left with 1 arrow length. Remember, the only time that you are using 2 arrows is when you are copying them from the table. From there, immediately you make a decision to say the first one will undergo oxidation, the second one will undergo reduction. You are able to say now you are using only 1 arrow. If you make a mistake of writing 2 arrows, you will definitely you won't get the marks. Calculation of EMF, I emphasized. I said, please copy the formula as it appears in the data sheet. So your job there is to copy the formula, and you know that I said A always comes before C. So the second one, that is your cathode, you will always subtract the anode from the cathode. So it's E of a cell, as I indicated in our example that we just did now. It's E of a cell equals to E cathode minus E anode. So if you want to check for galvanic cell, you are expecting your answer to be positive because we said it's spontaneous, which means that the answer, there is no energy that is added. In other words, we are saying galvanic cell is spontaneous and is exothermic, which means energy is released, not added. Hence, when you calculate the E of a cell or the EMF, it will be positive. It shows that it is spontaneous. I hope I've given you nice questions or exam tips when you are dealing with this question. Again, to say, I emphasize the use of the single arrow as well, to say all the time, you immediately when you decide which one will undergo oxidation and reduction, you will use single arrows. Do not omit the ion. For example, if you are writing copper 2+, you just write copper, it has lost meaning. If you write copper 2+ plus 2 electrons, instead of writing this, you write copper plus 2 electrons forming copper. It becomes wrong. The sign has been lost. So please ensure that the ions are always indicated and the electrons. Please, we're just pleading with you. When writing a formula for a 2-letter compound, the first letter must be capital. So look, for example, when you're writing chlorine, you can't write chlorine as Cl like that. No, the first one is a capital letter. The second one must be a small letter. I hope you understand that, so that we have to write the correct thing. When writing a reduction, you only remove the arrow pointing backwards. Remember, for reduction, you are having 2 arrows like that. For a reduction, now you only have 1 arrow like that. And for oxidation, obviously, you will have an arrow like that. So please don't forget, in real sense, the way I've showed you, you had the reverse one as the anode that I indicated on the table, which was the first one, and then the cathode, which was our second one there. So your arrows must be like that, just 1 arrow. Solutions in our cells must be the same N ions. For example, if you are having zinc and copper, the two must be in the same solution. Your N ion must be the same. For example, if we are having zinc is inside zinc sulfate, even copper must be inside copper sulfate. So our electrode, the 2 electrodes for 1 cell, they must have the same electrolyte. So please, we're just asking for that to say the N ions here. And the other thing which is very much important is to know that SO4 as an N ion is SO4 2-. So you must be able to say. So when you see SO4, you know that it's a 2-, which will make copper to be copper 2+. So sometimes we'll just give you copper sulfate. Then it is your responsibility to know that sulfate is a 2- and copper is a 2+. So don't forget that, so that you know. So we are indicating that you can't use zinc sulfate and copper chloride. The N ion must be the same for that particular reaction. I hope I've clarified that. For example, if you are using zinc chloride, it must go with copper chloride, like that. So the relationship must be of that of that fashion. I hope you have understood that. Let's look now at a question paper written in November 2020. Now, you see, when we ask you questions, we can start with anywhere from all the stuff that we've been doing. Look at this question. We're starting from a cell notation. So remember, if you don't understand cell notation, you might lose a lot of marks in this question. So it's very much important that you understand all the steps so that it becomes easier for you. In 2020, you were given a cell notation of the zinc, forming the zinc 2 plus, and then with the salt bridge, copper 2 plus forming copper. Now, if you were in this class, you will understand that this is what we said. We said the first one is the anode. We said A, B, C for cell notation. A for the anode, B for the salt bridge, and C for the cathode. So you are able to see that for the anode, we have zinc becoming zinc 2 plus. For the cathode, we have copper 2 plus gaining electrons to become copper. You know, we said red cat. So cathode will undergo reduction and anode will undergo oxidation. So you're able now to do that. Remember, in our study tips that I was giving you, I said you must first know the energy convention. When you say define the term galvanic cell, you will remember that we said galvanic is from chemical energy to electrical energy. You must write it in full, from chemical energy to electrical energy. Now, we can even ask you to draw the diagram for the zinc copper cell. So we can ask you to draw the diagram. Don't be lazy. You are having two beakers there that you are drawing. Don't forget. And then you must as well be able to indicate that you have the zinc electrode inside the zinc. I said if you are using zinc chloride, it will be zinc chloride. If you are using zinc sulfate, SO4, it will be copper sulfate this side. So you must be careful of that you are having that. Then you are able to have your copper there. Then you indicate that. You can put your voltmeter there. Then it shows that you understand what we're talking about. So immediately you must be, remember we said you need a salt bridge to complete the circuit. So you must be able to draw as well the salt bridge. So you draw the salt bridge. I hope you have seen this, or you will see this as you are doing it in your particular school. So you know that we have a salt bridge, and then because we have a salt bridge, it completes the circuit and it maintains electrical neutrality, which means because it's a salt bridge, we're expecting it to have a salt inside. So we can have a salt, we can have KNO3, silver nitrate, whatever the salt that we can have there. Remember, if we have potassium nitrate as our salt, you will see that the potassium is positive, the nitrate is negative. Hence, I said the cation ion, which is the positive ion, and the anion, which is the negative ion. So you know that our salt, it has a positive, which is cation ion, and a negative, that is an anion. Remember, we always said the cation ion will go to the cathode. The anion, which means potassium plus, will go to us. Remember, zinc, we said it is the anode, and copper is the cathode, which means the cation ions will move in the K plus will move towards the copper, and then the nitrate will move towards that. What is to do? To maintain neutrality. Remember, when the electrons are moving from zinc, we said the two electrons will move from zinc to copper because it's anode. So when the two electrons are moving, which means we are having more negative on the cathode there, hence the K plus, which is the cation ion, is coming to neutralize the solution that side. I hope you have understood that. So the question was, you must be able to draw the cell, show direction of electron. I've indicated there the direction. You see that arrow is showing that the two electrons are moving from zinc towards the copper 2 plus solution. So I hope you have understood that. Now the next question was write down two standard conditions. You see, we said two. So I indicated, you will say temperature equals 25 degrees Celsius, and we will say that our initial concentration is equals to 1 mole per cubic decimeter. So I hope you can see that whatever we're doing, you are able to answer as many questions as possible. To which half cell do the anions, you see now, the anions in the salt bridge migrate. So you have to know that the anions are the negative ones. They will migrate to the anode. The anode is the zinc. So you will say it will go towards the zinc half cell. So towards the zinc half cells, that's where the anions will go. Why? Because it's an anion. Remember, when zinc loses electrons, it becomes zinc 2 plus, which means it's more positive this side, because we have the concentration of the zinc 2 plus is increasing. Hence, the N ion, which is negatively charged, will come this side so that it can neutralize that zinc 2 plus. So I hope you understood that, and then you got your marks, explain your answer, which is what definitely what I was doing, to say that when zinc loses electrons, it will become zinc 2 plus, which means the concentration of the electrolyte this side is increasing on the anode. Then the N ions will come this side. In this case, NO3 minus will migrate towards the anode in order to neutralize those positive charges. So I hope you have understood and it makes much sense to yourself. Now, in this one, we are saying the anode now is zinc copper cell is replaced by an unknown electrode X. You're not supposed to be afraid when you ask questions like this one. You are supposed to say now they are saying the anode. Remember, the anode was zinc in the zinc copper cell. We said it was zinc forming zinc 2 plus, and then salt bridge copper 2 plus forming copper. So that is the anode. We said ABC. The anode is this one, is the bridge, this one is the cathode. So you are able to see that the anode now is replaced, which means now we no longer have zinc there. We are left with copper. From the table, you know that copper 2 plus 2 electrons, it gives us copper, which is positive 0.34. So we know for copper is positive 0.34 volts, the standard reduction potential. Now, it's 2 arrows there. We don't know whether it will lose electrons or gain, depending on what it's paired with. Now, the good thing about this, we know that EMF of a cell is given. E of a cell is given is 2,00. And then you know you are having E cathode minus E anode there. So you are able now to work it out to say we have a 2, we have the 0.34 there. Then if you were to transpose or to take the 0.34 that side, then it gives you the right answer. Then you are able to utilize the table to go and say if we were having 2, then you subtract that 0.34. What are you going to get? I think you are going to get negative 1.66. Then you are able to get that. Oh, it must be aluminium. So it's very much important for you as you do this question. Remember what I'm saying so that you understand where we're coming and where we're going. I'm saying to you that you are now saying EMF of a cell, we know EMF of a cell is 2, is given according to this statement. So you will write the equation of the EMF of a cell to say it is E cathode minus E anode. Then you are able to write E of a cell. You know E of a cell is 2,00. Your E cathode, you knew it has been 0.34 minus E anode. So you will simply transpose, take the positive 0.34, you take it that side, it becomes 2,00 minus 0.34. That gives you minus E anode. Don't forget, our E anode, it remains this side, is still minus. So when you get your answer there, which is 1.66, then that is equal to minus E anode. You have the responsibility of multiplying by negative both sides. So you get E anode is negative 1.66 volts. You go to the table, you look for negative 1.66. So immediately when you go to the table, negative 1.66, you will get aluminium. So you're able to identify X. That X, it was aluminium. Look at that, the beauty of science. So you are able to do that. Then we are saying practice all these type of questions so that you don't lose marks that are for you to take. So it was 5 marks. So you were able to say this is aluminium. Then you got 5 marks. Now they are saying now write down the half reactions taking place at the anode. You know that anode is undergoing loss of electrons, which will simply means that you copy your aluminium now. Remember now in your reaction you are having aluminium. Forming aluminium 3 plus 3 electrons. So that is the reaction that it will take. Maybe you're asking yourself how. Remember where there was zinc, now we're having aluminium, and according to the table, aluminium is aluminium 3 plus. and the salt bridge, we are having the copper 2 plus and copper, because we have replaced, we got that one. So you know that aluminium will form aluminium 3 plus. So you are able now to get that mark. And then we say which electrode will experience decrease in mass. Remember, the one that loses electrons is the one that will decrease in mass. So that will be our aluminium. Explain your answer. You are saying when aluminium loses electrons to become aluminium 3 plus, then it will decrease in mass because it's losing electrons. That was 22 marks, and I hope as and when you come across that question, you will be able to answer those questions. Now, with no wasting of time, I will want to talk to electrolytic cell. Remember, the difference here is galvanic cell. We said chemical energy is converted to electrical energy. It's no longer the case here. For electrolytic cell, we are now saying electrical energy is converted to chemical energy. You see now, we said galvanic is spontaneous, electrolytic cell is non-spontaneous. And we are saying this is endothermic, which means that energy will be added. Now, you got to be very careful here, because we are saying here we're going to use electricity. So we're going to use direct current. Why are we going to use direct current in terms of our power source? We're going to use direct current because we want the polarity of our anode and cathode to remain the same. Remember, if it's alternating, we're going to have a problem. So the kind of power source we use is a DC, because we want to have a positive and a negative. Another aspect that I want you to remember when you start with electrolytic cell is that now the positive one now becomes anode. Positive becomes anode. Remember, in galvanic cell, we're saying positive is cathode. But when we come here, we are saying positive becomes. I want you to underline that word becomes. Positive becomes anode and negative becomes cathode. So we say panic. Don't forget, electrolytic cell, we're saying panic. So we're saying the positive now is the anode. Why is it so? Because we're using direct current, your electricity, to force. Well, it's by force, this one. It's non-spontaneous. It's not a spontaneous reaction. We're forcing now that anode, that are positive now to become an anode. For example, as indicated to say, chlorine, a nonmetal, it's easy for it to gain electrons. But in this case, because we are using our DC source, you will see that chlorine will always want to gain electrons. You will find chlorine as the anode instead of it being at the cathode. However, it is more positive. You will see when we look at the values and that. So this is important as you start this section to say now we're going to use current, and it's direct current that we are using, and we're saying positive becomes anode. So you know that when you start this, it's that. So meaning that as and when you see a cell, remember, we will write our cell in this fashion. Electrolytic cell, we're now using that one beaker. You could have seen that in a galvanic we had two, but the two will now be in the same like that. So we're having that. So all you have to do is to know that, okay, this is positive, this is negative. You'll see that those, you will know the cell, that those longer one is our positive, that shorter one is our negative. Then you already know that the positive is anode. So you will know that the anode will be this side and the cathode will be this side. Remember, Leonard, we don't want you to claim that anode is on the left and cathode. No, that is not the case. Always you will look at what is indicated there, not by you saying we will always put the anode on the left and the cathode on the right. No, because we can switch them around, then you will have a problem. So it's just for you to understand that the positive one is that longer one, and then that shorter is indicating the negative part. Now the anode is positive, the cathode is negative. When we come to electrolytic cell, I hope you have understood that. Now, when it comes to definitions here, there are a few definitions that I would like you to always remember. Our first one is what is electrolytic cell. So you must know that electrolytic cell, it converts, we're saying it converts now no longer C to E, it now E to C, from electrical energy, from electrical energy to chemical energy. So we convert electrical energy to chemical energy in electrolytic cell. The next thing that you must know, remember, the electrolytic cell is a cell that converts electrical energy to chemical energy. However, what is electrolysis? So you have to know as well what is electrolysis, because electrolysis is a process. It's a process that converts electrical energy to chemical energy. So you have to differentiate. Another definition of importance that I would like you to remember is what is an electrolyte. So you must know what is an electrolyte. We're saying an electrolyte is a solution. This one we said is a process. This one is a cell. The definition is the same. The difference is that the other one is a cell, the other one is a process. Electrolytic cell is a cell that converts electrical energy to chemical energy. However, electrolysis is a process that converts electrical energy to chemical energy. However, electrolyte now we're referring to the solution that conducts electricity. So it has ions and is able to conduct electricity. So it's the solution that conducts electricity through the movement of ions. So when the ions are moving, it's able to conduct the solution electricity. So it's a solution that conducts electricity. So don't forget these, when you're dealing with this question, have these three in your mind. And we're saying this now, we are now adding energy. It's no longer exothermic. This one is now endothermic. And we're saying this cell is non-spontaneous. So don't forget, those are the most important things that I want you to always remember, that electrolytic cell, electrolysis, electrolyte, those three most important definitions when you are dealing with electrolytic cell. And we are saying this one is endothermic because energy is added. And then it's non-spontaneous because it means when you calculate EMF, we're going to get a negative answer, EMF in this case. Now, the other thing that is important is the basic components of electrolytic cell. To say, what are the components? How will you know that this one is the electrolytic cell? We're saying you will still have two electrodes as I indicated, but we're using one beaker to put the two electrodes. One is anode, and we said panic. The positive one now becomes anode, the negative one becomes cathode. And now, in this case, you will see some of these electrodes will be active, some will be inactive. I want you to get that because I will refer to active electrode and inactive so that you understand what I'm talking about. And we talked about the electrolyte, that these electrodes, the anode and the cathode, they must be inside the electrolyte, which is they must be inside a solution that is made up of ions and is able to conduct electricity. The most important part, learners, is to say you must know the formula and the name of electrolytes for all electrolytic cells processes that we are going to do. However, for technical science, it's nice because we are doing two electrolytic processes, which is namely electrolysis of copper chloride solution. So it's electrolysis of copper chloride solution, electrolyte solution. And number two, we're doing electroplating. So we do two processes. So we're expecting you to get total learners. Remember, I showed you that last year the average was 31%, but I hope you will be able to do well and get even much higher percentage in this section, electrolytic cell. Now, this is your question 5. So we're saying we're going to do electrolysis of copper chloride solution and electroplating. So for these two processes, it's important that you must know the formula and the name of electrolytes. Leonard, there are some small things that I want you to understand. If we say copper chloride as our electrolyte, copper chloride, you must know that copper is a group 17 element. So copper has -1. So that makes you see that -1 times 2 is -2. That makes copper to be +2. So you know that when you separate, remember, electrolysis, you are cutting, you are decomposing the copper chloride. If we say electrolysis of copper chloride, it means you're going to decompose it. You're going to separate it into copper 2+ and 2Cl-, you see. So that is the decomposition of copper chloride using electricity. So you got to know that when you write copper chloride like that, it's going to form 2Cl- from here, 2Cl-, and because these are 2, then we must have 2 copper 2+. So you have to understand that, and this is our electrolyte. So you must know the name is copper chloride, and the separation or the decomposition will form copper 2+ and 2Cl-. Now we must have a source of direct current. Leonard, we are not saying all the time we will show you which one is positive, which one is negative. So it becomes your responsibility to know the reaction that takes place at the anode and the reaction that takes place at the cathode, because you can be able to tell by when you are given the reaction. I talked to this, that is endothermic and is spontaneous. So I won't waste your time. We'll move. Now, the first one, electrolysis of copper chloride solution. Then what you have to understand here is that you can still use table. I will say use table 4A still. It will help you with that. So if I was to move back to table 4A so that you can know how to use this, you will see that we are looking for chlorine now. And chlorine now is given there at the top. We're given Cl2. I will write it here so that you can see it clearly. We're given Cl2 forming 2Cl minus. That is our first reaction according to this table 4A. And then we have copper 2 plus. I indicated that our copper will be copper 2 plus. Be careful, learners. I indicated we are using the copper 2 plus, the one that is forming copper solid. So it's a copper solid and a copper 2 plus, because we have different coppers that you will come across. We have a copper plus an electron forming copper there with 0.52. It's not the one that we are talking about during this electrolysis of copper chloride. And if you check again, we're having copper 2 plus here. You are most likely to choose this one, Leonard, is 0.16. It's not the one we're using, because the one that we're using is the one that has a copper 2 plus 2 electrons forming copper. So we must be able to find the right one, which is this one here. So it says copper 2 plus 2 electrons forming copper. Please, I'm pleading to identify the correct copper, because once you identify a wrong copper, the whole question now will become wrong. Now, if you have done this, now it becomes easy for you. Remember, we said we're going to use the zinc, then you write the Z there. You are able to say this one will be a reverse reaction, the next one will be a forward reaction. And they will say the first one is anode, the second one is cathode. So don't forget. So you are able to know already that we are going to follow. But remember, I'm using table 4A now. So it becomes easier for you now to say, okay, for the first one, I will write it in reverse. The second one, I will write it as is written. So you are able to write 2Cl minus forming Cl2 plus 2 electrons. You are able to write copper 2 plus gaining 2 electrons forming copper. So you see now, you know already that the first one, we are using only half reactions now. So when you say write down oxidation half reaction, you will write this one. When you say write down reduction half reaction, we'll go this one. Remember, we said the one with the bigger standard reduction potential will undergo reduction. So you know the cathode now is 0.34. And the anode now for the chlorine is positive 0.136. I want you to understand this. Remember, learners, when we started, I said the one with the high standard reduction potential will undergo reduction. In this case, because we are using electricity, we force the one with the highest standard reduction potential to undergo oxidation. Hence, you see, this one is positive 1.36. You are expecting it to gain electrons, but it's going to lose electrons, because we are using electricity to force the one with the highest standard reduction potential to lose electrons instead. So here, when we are doing electrolytic cell, we are saying chlorine is always anode. So you will find chlorine at the anode. So you know we have chlorine here. It's forming Cl2. When it forms Cl2, Cl2 is a gas. How do you see that the gas is being formed? Bubbles. So you will see some bubbles here will be formed because we are dealing with gases. So you have to know that because Cl2 is being formed, there will be some bubbles that will be formed. And on the cathode here, you are expecting that because we are gaining electrons, we are forming copper. Remember, learners, I indicated that we are going to have a beaker which is having both the two electrodes. Our electrodes. Remember, I talked about active and inactive electrodes. Remember, we said panic, the positive is the anode. So you know that the anode is this side. And I said chlorine is always in the anode. So this reaction of chlorine is happening at the anode. 2Cl minus is becoming Cl2 gas plus 2 electrons. However, in the cathode, you are having copper 2 plus gaining 2 electrons to form copper. This copper, you will see some deposits. Remember, our electrode, I'm saying, is inactive. So we're using carbon here. This carbon, this is carbon. So there's no copper, there's no chlorine in these electrodes. Remember, our electrodes must always be solid. So we were going to have a problem here if we were to use for chlorine. Chlorine is aqueous. So hence we are using carbon in all of them. So our electrodes are, I can say, they are inactive. However, when it comes to carbon, it will be plated. It will be having some of the deposits of copper. So you'll see some brown deposits that are being deposited on the cathode. So you can see that the cathode will increase in mass because there will be some deposits of copper on the cathode. However, on our anode, nothing is happening. It's inactive because chlorine is losing electrons, is forming that. So you will expect to see here some bubbles because the chlorine gas is being given off. So when you see bubbles, you see that there is chlorine that is being produced, which is given up on the cathode. We'll see some brown deposits. So those are your observations when you are doing the experiment, and it's always good to do the experiment so you are able to see this. And I hope you will do this experiment and enjoy yourself. Now we are saying, learners, we have this reaction for the loss of electrons. We have that one. So you know we wrote the anode there. We wrote the cathode here, which is now copper 2 plus forming gaining 2 electrons to form copper. So remember what we said? We said when you do the overall or the net, the first thing, don't forget, electrons must be balanced. So we're having 2 electrons on the anode and 2 electrons on the cathode. So they are balanced. So you simply cancel them when they're balanced. You only cancel them when they're balanced. Now, what's on the left, you write on the left. So on the left here, you have the 2Cl minus plus copper 2 plus forming Cl2 gas plus copper. So remember, learners, this is your 3 marks. So it's very much important. You are using the same method. You are saying the first one will reverse this one, then you write them the way you wrote them there. You cancel the electrons. After cancelling the electrons, if they are balanced, then you write what is on the left, what is on the right, on the right. So you are able now to see that you got your 3 marks. And that is your electrolysis of copper chloride. So it's as easy as that. So simply go to your table. For A, identify your chlorine, identify our copper 2 plus and copper. I'm still emphasizing, make sure that you choose the correct copper. Then once you do that, you know that the first reaction must be oxidation. The second one must be reduction. And when you get that, you are able to look at the electrons. If they are equal, balance them first. If they are not balanced, if they are balanced, cancel them. Then what's on the left, you write on the left. What is on the right, you write on the left. Then you are able to get your 3 marks for the overall or net cell reaction. So I hope you have understood this process that we refer to as electrolysis of copper chloride. Now, I'm hoping we're still moving together. I've showed you here that oxidational fraction should be 2Cl minus forming Cl2 gas and 2 electrons, and copper 2 plus will gain those electrons to form copper. So you can see we've indicated this as being brownish so that you can see that carbon, it was like black in color, and then when it's deposited now it becomes brownish so that you are able to see what is happening. And as well, I indicated here that the halogen will always form at the anode. Remember, chlorine is a halogen, so it will always be at the anode. So don't forget, I indicated the panic that the positive is the anode and the negative is the cathode. So I hope you have understood that. And come exams, no more 31% average in this topic, will get even a higher average. Now, our second process, which is remember I said we're doing these 2 processes. So our second one is electroplating. So now when it comes to electroplating, there are some small things that you need to see and identify, learners, before you answer the questions. Remember, during electroplating, we're having the object. 2 things. We're having a metal and we're having the object. So we want to plate the object with the metal. You see? We want this metal, for example, here, we are going to use the silver one. So we're having the silver as the what? As the metal. But we want this spoon to be silver. So our metal is silver, which is Ag. We want the spoon to be silver. Then what do? what do we do to plate this spoon with silver? Then what we have to understand is that our metal will always be at the anode. So the metal, which is silver in this case, will be at the anode. And you know the anode will lose electrons. So our metal will lose electrons as indicated as oxidation half fraction there. So you can see that our oxidation half fraction, that our metal is going to lose electrons. Then when it loses electrons, I want you to understand, electrons are moving from the anode to the cathode. So when it loses the electrons are moving here. As I indicated, as you can see the direction there, the electrons are moving there. As our electrons are moving, then you are able to see that, okay, now electrons are going that side. And then what do you think is happening now to the silver? The silver is becoming silver ion. The silver is becoming silver ion, Ag+. You see, now the silver becomes Ag+, which is in the solution. Remember, our electrolyte here is silver nitrate. So we're using silver, and the salt that we're using, or the electrolyte that we're using, is silver nitrate. So you know, I indicated that NO3 is a minus, which means silver is a plus. So you have silver plus NO3. So that is what we are having. So you are able to see that when silver loses electrons, it becomes silver ion. As indicated, the electron will move in the external circuit here to come this side. So when the electron comes this side, remember this, where the spoon is a negative one. So this silver plus that is formed when silver loses electrons, because it's positively charged, it will be attracted towards the spoon. So as it moves towards the spoon, silver comes. So the reaction taking place here, you'll have silver plus, which is this one, the one that is formed there. It will gain this electron that it has lost on the metal. It will gain it here on the spoon to form silver around the spoon. So our spoon now will become silver in color. So you can change the color of the spoon through electroplating. You can even make your spoon gold or any other metal that you want to plate on the spoon. So I've indicated that the metal will lose electron to become metal ion. Then that ion that is formed, it will gain electron to be plated on the object. So don't forget what we're saying. We're saying at the metal is the anode, and the cathode is at the object. Don't forget, cathode, object, and where there is a metal is the anode. So the metal, which is in this case, is silver. Remember, Leonard, we're not saying all our questions will give you silver. No, we can give you gold, can give you nickel, and any other metal that we can choose to plate with. So don't think that all the time it will be silver, and the electrolyte here is silver nitrate. Remember, when I was giving you study tips, I said you must know the formula and the names of the electrolyte. So our electrolyte for the silver one is silver nitrate. So we might ask you that in the question. I hope you have understood. So when I summarize this section, I'm saying to you, where we have a metal, this case is silver, if the metal itself will lose electron. So your objective, the first thing that you must do is to identify the metal. Which one is the metal? In this case is silver. So you know that our metal must lose electron. Then you must say which one is the object. In this case is the spoon. Remember, the reaction that's taking place in the spoon is just the reverse of this reaction, which is Ag plus an electron forming Ag. Then this is formed on the spoon. So you know the reaction at the anode is this one, which is loss of electron, oxidation. And then at the cathode is still the silver ion. So you're just copying this reaction from there, forming silver on the spoon. Then this is in our cathode. I hope you've understood that. And the metal will lose electrons, and the object, in the object, the metal ion, the very same ion that was formed by the metal, it is the one that will gain electrons. So if you know the reaction at the anode, then you just write the reverse reaction in the cathode. So hence we will ask you a question to say the concentration here of the electrolyte, the concentration of the electrolyte. You will see when I'm writing these big brackets like that, I'm saying concentration. Concentration of electrolyte remains the same. This is an exam question. We'll ask you why the concentration of the electrolyte remain the same. Why the concentration of the electrolyte remain the same? You must be able to say here, as you answer that question, that the rate, I'll write the answer here, rate of oxidation, the rate of oxidation is equals to the rate of reduction. So for that case, because you can see it's the same, what is happening? Ag is becoming Ag plus. The same Ag plus gains the electrons in the object and becomes Ag. That's why there's no change in the concentration of the electrolyte. So this concentration will remain the same because what is happening? Ag is losing electrons to become Ag plus, and then Ag plus is gaining the same electron that it has lost to become Ag on the object. So I hope you have understood that. So we're saying the rate of oxidation is equal to the rate of reduction. Hence the concentration of the electrolyte remain the same. I'm hoping you have understood this section, and as and when we start doing questions now, you will be able to answer questions. Now, I'll be happy if you can have an activity now just to look at this as well. But even before that, you have to see that during this electroplating, obviously because silver is losing electrons, so it must decrease in mass. Silver must decrease in mass because it's losing electrons. And then you can see what is happening on the spoon. We are plating it with silver, which means its mass won't necessarily be the same, so it will increase as well. So you have to understand. But when it comes to the electrolyte solution, concentration of the electrolyte, it will remain the same. Now, here's a question. I'm leaving the question for you to read that statement. Hope you read the question, you read the statement. The statement is saying the electrochemical cell represented in the diagram below was used for the decomposition of molten copper chloride. So it is copper chloride. As the reaction proceeds, the following observations are noted at electrodes A and B. Now, you see, learners, if you can not listen to this statement that you are given before and you rush to answer the question, you won't answer the question correctly. So it's important. There are some statements that we will give you before the question starts. Those are the have a highlighter, the highlight keywords there, and be able to get what we're talking about. Because if you look here, you will see we're not told which one is positive, which one is negative. You see, so this statement here will clarify that for you. But if you ignore this statement, you are going to have a problem because you won't be able to know which one is the anode, which one is the cathode. I hope we're together on that. Let's look at that. They say at A, there's a gas formed. Remember, we're talking about copper chloride. I said to you it's copper 2 plus and 2Cl minus. So I'm saying to you copper 2 plus and 2 chlorine minus. I'm saying to you now a gas is formed. You know a gas is formed. They said it's formed where? At A. Remember what gas is formed? It's a chlorine gas. So you're able to say, oh, this side we're having chlorine. So it's 2Cl minus. It's forming Cl2 plus 2 electrons. You can go to the table 4A and copy it. Sorry, and you will understand the reaction that is taking place in the anode. Now you are able to see that in the anode we're having 2Cl minus forming that, which means this side we're having copper 2 plus 2 electrons forming copper. So it becomes easier for you to be able to see that, oh, we're losing electrons this side, we're gaining electrons this side. So you know already this is A will be anode. Remember where oxidation occurs is the anode and B will be cathode. You see what I'm doing? I'm not rushing to answer questions. Yeah? Analyze the question, understand, bring all your understanding to the question to say, I know a gas is formed at the anode, and they said it is at A. So the only gas that is formed in copper chloride, you know, is the chlorine gas. So you will know that our gas is formed at the anode. So anode, you know, that's the reaction that is taking place at the anode. At the cathode, copper 2 plus is gaining electrons to form copper. So a reddish, remember we said a brown layer will be formed in the cathode. So you know that there will be that brown layer here around it as copper 2 plus gain electrons to form copper. So by analyzing this statement, you are able now to answer the whole of this question, because you can with no doubt go to the table and be able to say okay, we are having 2Cl minus from the table. If you copy them from the table, you will get, remember what we did is Cl2. I can simply go to our previous slide, the way we're doing this question, for you to just to remind yourself. I think it was on this slide. Yeah, it's fine. Let's utilize this one. So you're having Cl2. I think let's go to the table. Let's go to the table. Remember, we said we're using table 4a, so it's not a problem. It's not prescribed. It's a strategy that I'm giving you so that you get as total in this question. So I'm saying to you, when you arrive in the table, remember what you said. You said you will copy the first one, which is Cl2, 2 electrons forming 2Cl minus. Then you will copy the second one. Remember, we said the first reaction will undergo oxidation, will be reversed. So we write the Z there, then it shows that the first one will be reversed. The second one will write it is. Remember, we said when you copy them, you write them with one arrow. So it will be 2Cl minus forming Cl2 plus 2 electrons, copper 2 plus 2 electrons forming copper, as we wrote them there. Then you go and do what? And balance the electrons. If they are balanced, you cancel them. Then you are able to cancel the electrons. And then you are able now to say, okay, it's 2Cl minus plus copper 2 plus is forming Cl2 plus copper. That is your 3 marks. So with this table, you have answered that question. And then you can go to the questions now, because you went through the strategy to say, this is the strategy that I wanted to see. Then it becomes easier for you to answer the question. So I'm saying to you, learners, don't rush to the questions. Understand the question first, so that we are able to get as many marks as we can. Now, what type of electrochemical cell is represented in the diagram aside? It's on the side, this side. So this diagram that we are having, you know, is electrolytic cell. Why? Because we have a battery. We have a power source. Because in some of the questions, we'll ask you, why do you say this is an electrolytic cell? Then you must say, we have a battery, we have a power source. You know our power source, we say it's a DC power source. Write down the energy conversion that takes place. Remember, this one we said is from E to C, from electrical energy to chemical energy. You write it in full, learners, to make sure that you get all the marks. So it converts electrical energy to chemical energy. Now use letters A or B to identify the anode. So already you have done. Anode is A. Why is A? Because a gas is formed. And we said chlorine is always at the anode. So you know that chlorine is always at the anode. So where we have chlorine, which is a gas, then that is where our anode is. Cathode, you know, your copper 2 plus will be at the cathode. So that is B. So that is A, that is B. Remember, you're getting total because you analyzed the question first. Write down the formula of copper chloride. You see now, because we're not given copper 2 chloride here. So you have to know how to write the formula CuCl2. So you're able to write that. Copper chloride. What is the oxidation number? You see now that question I was telling you about of chloride ion in copper chloride. So you have to know chloride is Cl is group 17. So group 17, remember group 18 is 0. They don't have oxidation number of 0. Group 17 we said -1. So you have to know that this one is -1. And because we have 2 of that, -1 times 2, it must give you -2. Then that will make copper to be +2. So you know that copper is +2. The question was not about copper, it was about chloride ion. So you know they have a charge of -1. Don't forget that. So that is because this will form 2Cl minus. Now, what happens to the mass of the anode as the reaction proceeds? State only, increase, decrease, or remain the same. Then as this is a tricky question, it tricks you, and if you answer it without thinking, you will think that the mass will decrease because it's losing electrons. But remember, our anode here, I told you that we are using carbon electrode. So we're using carbon electrode, and the only thing that is happening is that chlorine is losing electrons. There's nothing that is happening to the carbon. It's just there to do what? To conduct electricity, to ensure that the electrons are able to pass. So nothing is happening to carbon in this case. In the cathode, we said the copper, the brown pigment, will be plated or will be deposited on the carbon. then we can expect its mass to increase. However, on the anode, we're expecting it that it must remain the same. So it's very much important that you think about it before you answer the question. Remember, when you're doing galvanic cell, zinc was becoming zinc 2 plus, we said it will decrease in mass because that electrode we say is active, but this carbon is an inactive electrode. So it's there just to allow the electrons to move through. It's not interfering with the reaction. So I hope you understand that. So we're saying it remains the same because the reaction that is taking place in the anode is this one. Nothing is happening to the carbon. Carbon is just our solid that we use. Remember, when we don't have solid, we can use carbon as our solid so that it can conduct electricity, can allow our electrons to pass through. So I hope you have seen this question and it gives you much courage as you prepare for your exam. Let's look now for another question again. In the electrolytic cell, 2 carbon rods. So at least here we told you that these are 2 carbon rods are used as electrodes, a concentrated copper chloride solution. Now, I want you to look at the difference. When we say copper chloride solution, it means in water, there is water there. But when we say molten copper chloride, it means we don't have water. So that is the only difference between activity 1 and activity 2. Is that activity 1, we are doing it molten. Activity 2 is in water. Hence, we are saying solution. The first one, I said molten. It means there was no water, but there is water on this one. Now, we are saying define the term electrolyte. Remember, we said an electrolyte is a solution that conducts electricity. So it's a solution that conducts electricity by allowing the movement of ions. So when the ions are moving, then there is going to be a conduction of electricity. I told you in the last question to say always look at the statement that will give you before. We are saying when the cell is in operation, a gas is just unfortunate. In the exam, it won't be highlighted in red. It is you who must highlight it. To say, they are saying a gas is released at electrode P. You know our gas, our favorite gas, chlorine gas, Cl2. So you will know that we are having a Cl2 gas that is released here. So you know where the chlorine is the anode. Where the Q is now, it will be our cathode, which means you will know that where there is chlorine is 2Cl minus forming Cl2 plus 2 electrons, and here is copper 2 plus 2 electrons forming copper. So you can see our reactions like that. And we are only doing 2 of these processes. So it's for you to practice this question many times. Do as many, all the question papers since 2018, starting with the exemplar paper. Be able to do all those papers. Then when you do those papers, practice this question 5, you will definitely be able to get total. Practice even the previous prelim papers. Then you practice. We are doing electrolysis of copper chloride. We are doing electroplating. Now, already when you have done this, you know the anode, you know the cathode. So your job has been made much easier. Then you can see when we deal with the questions now, write down the half fraction to explain the observation made at electrode P, which is this. You're just copying at P. They said there is a gas, so you're just writing 2Cl minus is forming Cl2 plus 2 electrons. Remember, we only have 2 equations, this and that. So you just have to know that one of the 2 it will be taking place. So we are saying practice. Electrode Q. What happens at electrode Q? We know now that we are having the copper 2 plus 2 electrons forming copper. Now, which electrode, P or Q, is the cathode? Which electrode, P or Q, is the cathode? So already you have made your decision. You know that Q is the cathode. Give a reason, because you can see there is what? There is copper 2 plus is gaining electrons to form copper. Write down the overall cell reaction. You see, you're enjoying yourself. Remember, I said it to you for you to enjoy this section. Copy the 2 half reactions from table 4A, and after copying them, you follow those steps. So please, I'm reminding you, I'm repeating it. I'm saying you'll go to the table, you will get your Cl2 plus 2 electrons forming 2Cl minus, which was positive 1, I think it was positive 1,36. And then we have the copper 2 plus 2 electrons forming copper. This was positive 0.34. We said, well, because we are using electricity, direct current source, endothermic reaction, non-spontaneous, we are going to force the one with the high standard reduction to lose electrons. We said chlorine will lose electrons. So you know where there's chlorine is the anode. So you know that this one will reverse, this one will go forward. Then it becomes easier for you to say 2Cl minus forming Cl2 plus 2 electrons. And then to say for the forward direction, we're having copper 2 plus gaining 2 electrons to form copper. Look at that. Then the electrons are balanced. Don't forget that. Electrons, when they are balanced, you cancel them. Then you write what is on the left in the left. So you have in the left here, you have 2Cl minus plus copper 2 plus. This is forming Cl2 gas plus copper. Remember, you're getting your marks there. We gave you 2 there, but usually we'll give you 3 marks for that particular question. So I hope you can see that is practice. Do many questions, and then you will understand this, and you will do very well in your exam. Now let's look at our other question now, which in this case is electroplating. How do I know that it's electroplating? Because I can see we're given electrode Y and we're giving ion metal. So I can see a metal. A metal must be an object. You see, I'm able to see we have the object. Here, you see, we are saying that the metal is iron. It's made up of iron. So don't be confused by iron and then you rush to the table and look for iron. Remember, I said the object is an inactive. It's just standing there waiting to be plated. It's not going to lose or do anything, undertake the reaction. So there won't be no ion that is losing or gaining electrons. Electrons in electroplating are lost by the metal, and the metal ion that are formed by the metal, they are the ones that gains the electron. So the ion won't be taking part there. The only thing, if I'm you, I will just see the metal. I won't even see that ion. I will see a metal that needs to be plated. Now let's read the statement. It says, the simplified diagram shows an electrolytic cell used at an electroplating company. So we have companies that are doing electroplating. They want to coat iron metals with silver. Oh, they're telling us that it's silver we're using. Now you have to download now to say, we did this section. We said if the metal is silver, the solution, which you call electrolyte, it must be silver nitrate. Don't forget. If the metal is silver, our solution will be silver nitrate. So that when we ask you that, you see, we didn't tell you whether it's positive or negative. We just tell you that it's a DC power source. Why? Because we want you to be able to tell us which one is negative, which one is positive. Remember what we said? We said the metal must lose electron. The object is doing nothing. It's just waited to be plated. So you know silver must lose electrons here, which means here on the cathode, because this will be the anode where we have the loss of electrons, where we have the gaining of the electrons, where we have the object. The object will be at the cathode. So you have to know that on the object, we are simply writing the same reaction in a reverse manner. So we're simply starting with Ag plus, forming Ag. Remember, learners, what I said too. I said we will always say the concentration of the electrolyte remains the same. Give us a reason. I said the reason is that the rate of oxidation is equal to the rate of reduction. Now let's go to the questions, because once you have done like that, you can see that you are done with this question. In fact, you are just going to collect marks. So hence we're saying analyze the question first, understand the question. Then when you go to the questions themselves, you are able now to get the marks. So let's go to 3.1. It says state the direction of electron flow. Where will the electrons flow from? You know our electrons are flowing from the anode here to the cathode. So they will move from silver towards the ion metal. So our electrons, they will move from silver towards the ion metal. Because silver, they always, even in galvanic cell, electrons always move from anode to cathode. Now, what physical change You see this issue of physical change, which is the mass and all that. What are the changes that will happen at electrode Y? Remember, Y is losing electrons, so you are expecting it to decrease in mass. So you will expect this to decrease in mass. Physical change in Y, because it's Ag forming Ag plus an electron. So it's losing electrons, so it must decrease in mass. However, you expected Ag plus concentration to increase, but it doesn't increase because the same Ag plus is the one that gains electrons to form silver on the metal. So the concentration remains the same, but the mass of the metal will do what? Will decrease. I hope you're enjoying and we're moving together. What type of reaction? Is it oxidation or reduction that is taking place at electrode Y? Look at that. Already you have indicated that the metal will lose electrons to form metal ions. So you know that is loss of electron, which means it's oxidation. You're able to say, at electrode Y is where the metal is, that is oxidation. Write down the equation of the half reaction that takes place at the ion metal. Look at that. You're just writing that opposite of the oxidation. This Ag plus an electron forming Ag. 2 marks. Name or formula of electrolyte X. Remember, it's silver. It's going with silver nitrate. Just imagine, we have answered all the questions. You have made your own memorandum. So, hence I'm saying, analyze the question, write all that you know, and then when you go to the questions, you'll just be able to provide us with the memo, and you can get total in this question. The question that I've emphasized since I started to say why the concentration of electrolyte X remains constant. We said the rate of oxidation is equal to the rate of reduction. So you don't have to forget that. We're saying the rate of oxidation is equal to the rate of reduction. Just see, you got total now in that particular question, and that's what we're expecting of you. Now, as I conclude, I just want you to remember, learners, to say we can use any metal. We don't use silver at all times. Look at this. We're using nickel electrode. So this time we're using nickel. And if you go to the table, you'll be able to see that nickel is a nickel. It has a 2+. So we have that. So you will see that in the table. If you go to the table, remember where the metal is. We said it's the anode. And remember what I was saying to you. To say it doesn't mean that the anode will always be on the left. You see, we'll put the anode on the right. Then in the exam, if you are claiming that the anode on the left and that, then you're going to lose marks when you're not supposed to. So I'm saying to you, the anode, how do you know that it's an anode? It's a metal. So the metal is the anode. What do we have here? A plastic ring coated with graphite. So you have a ring here, which is plastic. So it means we want our plastic ring to be nickel. So nickel must lose electrons. Remember, in the anode, nickel, you can even go and look for nickel in the table. So you will see that nickel is a 2+, then nickel will lose electrons where? In the anode. In the cathode is nickel 2+, that gains the electrons. Nickel 2+ will gain electrons to become nickel. So that is now, this is now plated with nickel. Look at the beauty of science. The rest of the questions, it will be what we have been going through. To say, define the term electrolyte. We said it's a solution that conducts electricity. We said, give one reason why the plastic ring must be coated with graphite. Remember, we want to be able to, for us to be able to plate, we want something that is solid. Hence, we have to put carbon around it. Write down the half reaction that occurs at the plastic ring. We're just writing that for 2 marks. Name or formula of the reducing agent. Remember, we're saying loss of electron is oxidation. That's where you will get your reducing agent. Remember, the agent is on the left of the half reaction. So nickel becomes your reducing agent. Now, name or formula of the, I wrote, give a reason for the answer. It's your reducing agent because it's the one that is losing electrons. So we have indicated there. Which electrode? The ring of the nickel is the cathode. Already we have indicated that the cathode is the plastic ring because there's gaining of electrons. Give a reason. Because nickel 2+ is gaining electrons to form nickel that is plated on the what? That is plated on the plastic ring. I hope, my learners, you have enjoyed our lesson and you are ready now. You are saying, come galvanic cell, come electrolytic cell. As and when you decide to use the table, ensure that you use them correctly and you are able to get everything correct. It is in your hands to create a better world for all who live in it. Thank you very much.